All right, so we are going to continue kind of with applications of percents. And again, applications are just ways this works in the real world. I'm actually going to flip it, and we're going to do the second half of the lesson first. So if everybody can go to this slide that says discount, because we started that actually last hour. So discounts, again, can somebody remind me what a discount means? Some amount off, right? Like if it's a really good discount, half off would be great. This might not be a half off discount. So describe the process to me. What's the first thing you should do? Multiply. Always, regardless. If it's tax, tip, discount, you always want to multiply the percent first. So the first thing you really have to do is change your percent to a decimal. So change your percent to a decimal, then multiply. And then if it's a discount, what do? Subtract. So take a look at this problem, which says admission to the museum is $8. Students receive a 15% discount. How much is that discount? And then how much do students pay? So this is basically just splitting it up into the two parts. So the first thing we're figuring out is the discount. So if they receive a 15% discount, what percent? That becomes 0.15. So I'm going to do 0.15 times what? Times 8. Which is going to give me 1.2, thank you. All right, and then so that's how much the discount is. And then how much will the students pay? $6.80. How did you get that, Daniel? No, you didn't. That would not have given you $6.80 because that number is smaller than the original. So Daniel, you did what? Subtracted. And why do you subtract here? Because it's a discount. So you take your original ticket, which was $8. You find the percent, so that's 120, and then you subtract it to get the new cost of the ticket. Remember, if it's a discount, the number should end up being below the original. It should be below the original, a lower amount. Because otherwise, if you say you're getting a discount and then you end up paying more, is that a discount? No, that is exactly the opposite of a discount, right? So that's like sales tax or tip. Okay. In fact, that is what we call markup. All right, so if Christo uses a coupon and pays $7.35 for a pizza that normally costs $10.50, I want to figure out the percent discount. So that's what we're going to talk about today, how to basically go backwards from what we did, okay? So we're going to skip this one for now. And we're going to talk about markup, and then we're going to come back to this once we've done the percent discount. All right, so let's talk about markup for a second. How many of you guys have ever had, I don't know if people do this anymore, I'm probably really like making myself seem very old, but how many of you guys have ever had a lemonade sale? Okay, so some people have had a lemonade stand, just a few. Can you imagine yourself having a lemonade stand? What would you need to do if you were going to have a lemonade stand? You would go get some lemonade, right? Okay. And you can be like really Martha Stewart about it and get like some actual lemons and sugar, or you can do with it. It's awesome. Good on you. I went and bought Country Time. Yeah, because I am not Martha Stewart. So I went and I bought my Country Time, right? And what else do you probably need to buy? You're adding sugar to Country Time lemonade? Oh, Reggie. That explains so much about why you are the way you are. All right, so I do not add sugar to my Country Time. I just am going to get Daniel water, right? So I also need water, but again, I'm cheap as ever, so I'm going to use Houston tap water. So that I'm going to take off my list because I'm not going to pay for bottled water. But I'm going to buy some ice, all right? And I'm going to buy some cups because I don't know how else people will drink it. I have a pitcher at home, so I'm good. I can just make it in my pitcher. But I had to buy some stuff, right? Let's say that I spent $20 total. Let's say I spent $20 total, all right? And I'm hoping that I want to sell 50 cups of lemonade, all right? But I want to sell more than $20 worth of lemonade, right? How can I do that, though? If I spent $20, and how do I make more than 20 then? Markup? Why, Reggie, what does that mean? You charge more than you paid, right? So if I'm going to the store and I'm buying my Country Time lemonade mix and my cups and I pay $20, I'm going to charge more than what the lemonade actually costs to make, because ultimately, what's my goal with a lemonade stand? I want to not only get my money back, but then I also want to earn a profit, because otherwise, why am I sitting out there in the hot Houston sun with my little sign that says lemonade, 5 cents a cup, or whatever it is? All right, I'm not going to, you're a businessman. We talked about this. You're going to be a salesman. I'm not. I don't know why I did to begin with. But okay, so markup is when you mark up the cost of something in hopes that you're ultimately going to make a profit. So everything you buy is marked up. Like, let's use Parker uniforms as an example, because they are outrageously marked up, right? So the skirts that you buy, how much are the skirts that you buy? 40? $43? I'm horrified by that. Okay. Do you think that it costs Parker uniform, whoever they use for their manufacturer, do you think it costs them $43 in materials and labor to make that skirt? No, but they mark it up. Why? Because they want a profit. And they specifically are in a really good market for that, because do you have another option? No, you don't have an option besides Parker uniform. So you have to pay that $43 because Krista Ray has says that you need to wear this Parker uniform skirt, so you don't have an option, right? So that's called markup. It costs probably, I don't even want to, I don't even want to, it's sad how much it actually costs probably to make that skirt, right? But they mark it up. And they mark it up, and that right here, wholesale cost, that's that like $10 or whatever it costs to make the skirt. That's how much it actually costs for materials, for the person who operates the machine that makes the skirt. That's our wholesale cost. And they mark it up a certain percent. Okay? So let's say, for example, Caleb here buys necklaces at a wholesale cost of $48 each. And then he marks up the price by 75%. And he sells the necklaces. So I want to figure out how much he's selling them for. So what do you think I would do to figure that out? Always multiply first, and then it's a mark up, so I'm going to add. Good. So what am I multiplying?
48.
Good. Someone do that for me. 84? All right, so 84. And then what do I do to figure out the total cost? 84 plus 48, which gives me 132. All right, so $132. So Caleb sells a necklace for $132. Did he pay $132 for it? No. Why is anyone buying those necklaces? Oh, maybe he's telling people it's made of real. It could be made of real stuff. All right, but why would anyone do that? Why do you ever pay anything more than wholesale price?
Because they don't know the wholesale price.
Yeah, do you know where to go to get, like, maybe, yeah, maybe. All right, but even stuff online is probably not wholesale. So a lot of times, like, we don't have access to wholesale prices on stuff. Like, I can't just go to a necklace factory and buy one necklace. Like, if I want to buy wholesale prices, I probably have to buy how many? 3? Probably more than that. You probably have to buy a ton of them, right? Because the assumption is that people that are buying those are selling them and they're like at a store. All right, that's like Costco, Sam's Club, when they're called wholesale. That's why everything there, when you buy it, like, you don't just get a ton. What? No, oh, I thought you said used. I was like, it's not used, but it's huge, right? Like, you don't get a tiny jar of peanut butter when you go to Costco. You get like 3 48-ounce jars of peanut butter, and it's huge, right? Are you guys okay? Okay, it's dead. All right, so when you go to Costco to buy, Hannah? Was that not 84? I just listened. It's what? Oh, and that's where 84 came. Oh, you were working too fast for me. All right. Thank you, Hannah. No, you're good. So the total is 84. All right. No, you did it right. I'm sorry. You skipped my middle step. Okay. So anyway, what was I talking about before the bug? Costco peanut butter. So that's why when you buy stuff at wholesale cost, it's like in a huge bulk. You can't just buy a little thing of peanut butter. So people might not want stuff in wholesale because like if you don't have a giant pantry, what do you do with all that peanut butter? But at the end of the day, if you can get a wholesale, it's going to be a better deal, but you guys don't have access to it. Do you have a single way to get that skirt besides Parker uniforms? No, you can't. You probably try to find it and you can't, right? So when things are wholesale, you don't have access to it. That's why you can't pay wholesale prices. But again, markup, same as sales tax, same as tip. How do you find it? Multiply, and then what do you do with it? Add it on. So the only time you should be subtracting is if it's a what? Discount or like a coupon. If you see the word coupon, is the same thing as discount. Okay? All right, so we are going to go back now, and we're going to talk about percent change. So percent change is basically trying to figure out what the percent of change was. So rather than using the percent to figure out like the dollar amount change, we're going backwards here. All right? And the way that we do that is we use this formula right here, which is percent change. I'm just going to rewrite it. I'm literally rewriting the exact same thing that's already here, just in my own handwriting. All right, so percent change is equal to the amount of increase or decrease all right, so that's the amount that something went up or down over the original amount. All right, the amount of increase or decrease over the original amount. And that's going to give you your percent change. So let's take a look at an example of this. Okay, this is again, here's our same formula. So if you didn't get it copied and you want to, here it is right here. Percent change, amount of increase or decrease, and original amount. So the problems are going to look something like this, from 25 to 49. Notice there's no percent in there right now. That's the thing we're trying to figure out. We're trying to figure out the percent. We don't have a percent. We just have two numbers. So it went from what? 25 to what? So first question, is that an increase or a decrease? It's an increase because it went up. Okay, this number, amount of increase, how could I find how much it went up by? Emily? Exactly. So 49 minus 25. So 49 minus 25 is going to give me that amount. 9 minus 5 is 4. 4 minus 2 is 24. So my amount of increase is 24. All right. And my original amount, I don't have to do any work for it because what was it? 25. All right, so it went from 25 to 49. So 25 is my original amount. I found my amount of increase by doing what? Subtraction. Okay, so I found my amount of increase by subtracting. So then this right here is a fraction, but every fraction is a what? Division problem. So someone on their calculator, go ahead and do that division for me. 0.96. But remember, we're converting to a percent, so that ends up being good. Perfect. So that's a 96% increase. It went up 96%. Okay. B, from 50 to 45. Is this an increase or a decrease? It's a decrease because it went down. Okay. That would make you think it's going to be what type of number? Negative. We're not going to work in negatives. All right, we don't have negative percents, so just ignore the negatives. We still do this the same way. So I'm still going to start by finding my amount of decrease, which I'm going to do by what? Subtracting. So I'm going to subtract, just always do bigger minus smaller. So I'm going to do what? 50 minus 45, which equals 5. So that is 5 over, what's my original amount? 50 is my original amount. That's the one I'm starting with. So it's 50 because 50 is the one I started with. It says from 50, so that's where I'm starting. All right, and when I divide that, I end up with 0.10, which is what? 10%. So that was how much of a decrease? A 10% decrease. Good. Reggie. Did this number get bigger or smaller? 50 to 45? 50 to 45? If you had $50 and now you have 45, smaller, so it's a decrease. Yeah. Think of it like money. If you had this and now you have this, did you get money or did you lose money? Yep, so it's a decrease. All right, so that is a 10% decrease. The process doesn't change. It's just going to change which one you put in your original and which one you subtract, like which one starts. Okay, so go through the steps with me. First thing you should do is what? Subtract, and that gives you your top number. Where's the bottom number? The original, which means it should be your, if they're written like this, it's going to be your first number. All right, if it's in a word problem, look for the actual word original, okay? Or starting cost, or like if I started with $20, that would mean original, okay? Okay. What about this one? Find the result when 30 is increased by 20%. What's different? What do we have here that we didn't in the other two? We have the actual percent. So let's go back to, I'm going to rewrite the formula. Percent change equals amount, increase or decrease. I'm going to abbreviate amount. Increase or decrease over original. Okay, so again, we have a formula, but it's just about figuring out where to plug the stuff in, right? Well, what's the only one with the word percent in it? What's the only part of my formula with the word percent in it? The left side. So that's where what has to go. But again, can we write it as 20%? No, so we have to write it as 0.2 or 0.20. Those are the same. All right, equals, find the result when 30 is increased. So what's 30? Original. 30 is your original amount, so it's going to go where? And if I don't know this, what do I call it? X. Good. I don't know it, so I'm putting a variable in there. If I don't know what something is, call it X. Okay. How do I do this? Multiplication. Why? What kind of math is this? Division. How do I undo division? Multiplication. So I'm going to take these two and do what with them? Multiply. Good. So do 0.2 times 30. 6. All right. So that's the what? That's the amount of increase. So if I want to find my end result, what would I do? Add it on. Why add? Why not subtract? Very good, Reggie. Perfect. It says increase, so at the end you should add. If it said decrease, what would you do? Subtract. So if I had 30 and I increased by 6, now I have what? 36. This is like the icing on the cake of, this is a hard problem because there are lots of little steps, okay? So this is really awesome if you can get the 6. But then try to remember the icing on the cake step is what's your end result? All right, increase, add, decrease, subtract. Okay, let's try one more and then I want you to do some practice. So let's take a look at this one. Find the result when 65 is decreased by 80%. So where's the 80% going to go? Left side, and I'm going to write it as 0.80 or 0.8. All right, equals, where's the 65 going to go? No. 65 is on the bottom because that's your original. So what goes on the top? So I'm going to have to do what? Multiply 65 times 0.8 or 0.80, which gives me 52. And then last icing on the cake, what do I have to do here? Why subtract? So I'm going to subtract what two numbers? Perfect. Great job, guys. 13. All right. This is like the bulk of your partial credit. If you get this, that's what I'm looking for. And if you get this, that's like full credit. You got it. But the bulk of the work, I would love if I can see you guys using that formula. Okay, that is, if you can plug stuff into formulas, half of algebra is just, can you put the stuff in the right spot? All right, so again, we ended up with 13 because we subtracted because this keyword here decreased. All right, what do you think the biggest mistake people make is? If you had to guess. It's actually not adding or subtracting. Where would you add a 1? Okay, maybe they put a 1 in on the x. People put this 65 in for the increase or decrease, like in the top all the time. So they put the stuff that should be the original, they put in the increase-decrease spot. So watch out for that. That's kind of like the pothole that people step in all the time. All right, good timing. Okay, so there's a lot up here. I don't want you to do them all. I would like you to do, so these first 3 are just like the first ones we did. So you're just plugging them into you're using the same formula for all of these. These last ones are the harder ones. So I would like you to do 16, 20, 24, 28, 29. I'm going to mark them right up here. And I'm going to put the formula up here as well. So 16, 20, 24, 28, 29. Okay, so discounts, markups then, if you have a percent change problem, like this is B, so we did A, so we're skipping to B now. All right, so Christo used a coupon and paid $7.35 for a pizza that normally costs $10.50. Find the percent discount. So again, I'm still using the same formula. I'm going to use just a little bit of a shortcut, inc or dec for increase or decrease, and then orig right here. Okay, so I'm looking for the percent discount. What do I know? I know the original, and I also know a new price, right? So where is my original? Is that the original? Why is 1035, or how do you know that 1035 is the original? Because it normally costs 1035. So does it, 1050, sorry. Does it say the word original in there? No. So what do you have to do? Find a clue in there, a context clue. And the context clue in there is, Savannah, the word normally. So normally, usually, originally, it costs $10.50. So I'm going to put $10.50 where? At the bottom. Okay. How do I find my amount of increase or decrease? Subtract what? 1050 minus what? 7.35, because that's how much it costs now. So I'm going to subtract that, and I end up with what? 315. Thank you. All right, so that number goes where? On top, 315. And that's going to give me my percent change. So I'm going to do what kind of math here? Divide. How come in some of the problems at your boards you multiplied? Yeah, we had the percentage and we had a variable over here. Good. Okay, so I'm going to divide here 315 by 1050, which gives me what? 0.3. What? 0.3 repeating? Or just 0.3? So 0.3. And is that a percent? So what do I do? And I end up with 30%. Very good. Is that a 30% increase or decrease?
Decrease.
Decrease. Why?
Because she's paying $7.
Yeah, it usually costs $10.50, but she only has to pay how much? $7.35. So she's got a discount, basically. She's got a decrease. And it was a 30% decrease. That right there, as hard as it's ever going to get for percent increase and decrease. That is a very difficult problem because there's a lot to it. You've got to do a lot of reading and figuring out stuff and then figuring out where to plug it in. So that's probably as hard as it's going to get. Okay. Lars, they picked the weirdest names. Lars purchased a daily planner for $32. The wholesale cost was $25. What was the percent markup? So again, you guys will notice, what do I do pretty much every time? Okay, I write the formula pretty much every time. I do that, like, could I do this mentally? Yeah, probably so. Could you guys do it mentally? Maybe so, right? It doesn't take me that long to write the formula, and it really helps me organize my thoughts. I am going to continually, you will see me do that all year long. I need my thoughts to be organized if I'm going to get these right. Because especially as algebra continues to get harder, you're asking your brain to organize stuff that's longer and longer and longer. So writing the formula, I think, is always a good idea. Okay, I'm looking at this. He buys a daily planner. It's $32. Wholesale cost was $25. What was the percent markup? So I don't know my percent, so that's going to stay blank. What was my original? 25. Because what's kind of my keyword there? Wholesale or? What does the word was indicate? It used to be that, but now it's something else. So your original was what it used to be, and now it's something else. So like was or past tense, that's going to help you. Wholesale, also going to indicate that's your original. So 25 is your original. All right, and then do I put 32 on top? No. What do I put on top? I subtract it and I get 7. So you've got to do that subtraction to get that top number. Remember, that isn't just the number they give you. All right, so I'm going to do 7 divided by 25, which gives me 0.14, which gives me 14%. So my markup there was 14%. Is that 0.42? That's not right. All right, thank you. I was like, that doesn't look right. All right, 0.28. 0.28, which ends up giving me 28%. Okay, 28% markup. So not as bad as Parker uniforms, but you're still getting marked up there. All right, you're paying more than you could have paid if you bought it wholesale. All right, so markup means price goes up. So that means you would add or subtract? Add. Discount means price goes down. Good. What's the formula for these? Percent equals increase or decrease over. How do you find your increase or decrease? Subtract. Very good. Subtract. All right. Do, for your exit ticket, do the A's. Just the A's. So 1A, 2A, 3A, and 4A. So just do the A's.